question. There are some from the RocketPY team. How did you determine the shock and vibration loads that the rocket would experience?
It's a great question from RocketPY. The easiest way to do it is if you've flown a very similar rocket in the past and have flight data from where that part will be, an accelerometer near the base of the part or on a similar part. And so you can be pretty confident that the flight environments that it will see will be very similar, or what you've seen in the past on a similar trajectory, similar design. You'll have to do some scaling, but pretty simple things like that. Where it gets really hard is when it's a brand new launch vehicle or a brand new location on the rocket. And there you have to do what I would say are some pretty hand-wavy things, go into some technical papers someone's written 40 years ago with kind of these curves of scaling factors of how will vibrations be attenuated or changed in these directions, and try and come up with something there. And then all these things you're gonna validate with a finite element model that you run through a dynamical simulation. So that's a mathematical model representing the launch vehicle, and you'll be able to pull out accelerations and forces at any place you ask of it. The problem with those is just they're very finicky. We have definitely not mastered the modeling process, and so you want both the data to look at the flight environments and the analysis model, and you want the analysis model to match the data. But neither are really remotely close to perfect. So that was a very sobering thing as well. And then I see they also asked about how we would simulate if the system could survive the loads. That was a combination of analysis and testing. Different parts had different requirements. Testing is definitely a lot more confidence inspiring. I think you learn a lot more in a test, whether that be a static test or a vibration test, but it's more expensive. It's more time expensive. The part fails that test. It can set you back on the schedule front a lot. And you have to build a test article and run it through a test campaign. So you're trading schedule cost, time cost for having a more rigorous test. So it reduces risk more. Often it reduces risk more. Lower safety factors, so you can reduce the mass of the design. If you're going to just do an analysis to prove out that your part can handle some given vibration environment and some static equivalent load of acceleration, you have to use a much higher safety factor. That's called a qualification by analysis only. It's one of the highest safety factors that we carried in terms of the design of the parts. Tons of parts did go through that because it's not worth the time cost to run them through a test campaign. A designer needs to think about those trade-offs. Is this part complex and important enough that we need to run it through a test campaign? And then how do we make that test campaign as accurate as possible and as low cost and schedule cost as possible?